Today we're in section 4.4, writing and graphing inequalities, okay? And we're in our books on page 146. It's important that you look at the chart, okay, at the top of page 146. I'm not going to ask you to write down these keywords because it's going to take too much time. But I need you to use this as a reference when you're doing your homework and your review sheet. Now, by the time Monday comes around, you need to be familiar enough with them that you can, basically translate the phrases we're about to do without the key. Basically, you're not going to have it on your quiz, okay? So you need to be able to recognize, can we recognize that less than and fewer than means less than? Okay, it's literally you're saying the word, okay? And greater than and more than, okay? So those are pretty simple. But when we get to at most or no more than, we have to kind of think about that a little more. If I say you can be at most 13 years old to get into the playground. At most means 13 years old is the absolute most. Well, as soon as I say it in what we call a real life scenario, it becomes pretty easy, right? It's pretty simple. But when I look at it in some of these words, sometimes it can get confusing. So that's kind of what I usually encourage you to do is think, okay, well, if it says at most, what if it's at most 13? Well, that means 13 can only be the most, so that's less than. Any other number has to be less than that value. Same thing goes with at least or no less than. And you're going to see these, again, less than or equal to, okay, that's like a gimme, that's obvious. But some of the other ones I might have to think about a little more. These key words are really important for us to know in order to be able to write inequalities. That's what the lesson is all about today. All right, so let's look at these real world situations. You have a couple of these on homework and on your review sheet that you're going to be working on tomorrow. I'm going to say in this sentence, at least 3 students from our school are in a chess tournament. All right, so I always want to start my inequality with a variable, okay? And this variable represents some value that would make the inequality true, okay? With inequalities, there's multiple values that can make it true. So this number, okay, represents at least 3 students. So if I say at least 3, is 3 like the lowest amount or the highest amount? Or what do you think? No. If at least 3 came, that means that some number has to be greater than or equal to 3. All right? If I said at least 5 of my friends are going to come to my party, what's the absolute minimum number? 5. Could 10 come? Maybe. All right? So what are some values that can make this inequality true?
15.
15. Any number greater than or equal to 3, right? So 15 or 5 or 6 or 32, okay? So you're going to have to give some values that would make the inequality true. Guys, it can be anything that's greater than or equal to 3. 5, 12. I think I asked for 2 on your review sheet, 15. All right? So now let's try to write an inequality for your ring size. I said your ring size is less than 7.5. Again, just use N. I guess you could use R for ring if you wanted to, but try to write an inequality for the real world scenario. Anybody think they have it? Okay, well, give me the inequality first. Anybody think they have it? All right, Miles, what do you think?
N
is less than 7.5. Raise your hand if you got that. N is less than 7.5. So now give me an example that's less than 7.5. Give me any number. All right, 1. You can't have a negative ring size, and they usually go by halves. 5, maybe 6. Okay? All right, now let's try the last one. A temperature is no more than -1 degrees Fahrenheit. Again, think about it. It's no more than -1 degrees Fahrenheit. So again, we use our variable, but it has to be no more than -1. So what inequality would go there? Try to fill it in and give me 2 examples of values that would make it true. What would you put, Gabe? Well, it can be equal to, but is it less than or equal or greater than or equal?
Greater than.
It can be no more than. So that means that my value itself cannot be more than -1, so it has to be less than -1. Okay? All right, so my value has to be less than or equal to -1. So what are some possible solutions here?
4.
-2,
-5.
-5, -6, really any negative number, right? Any negative number. Okay, so any questions on writing inequalities from real world scenarios? Any questions? So now let's test, oh sorry, we've got one more. You have 2 of these on your review sheet and I think 2 on your homework. We need to now write inequalities. We are not solving anything, but we're just simply writing the inequality, pulling it out of the phrase. It says a number, and in this case it's going to be x, plus 5 is less than or equal to -7. So again, I'm going to pull these values out and write it in an inequality. All right, a number x, so it gives me the variable. How would I represent plus 5? What would I write in my inequality? Plus 5, right? An addition sign, plus 5. How could I write less than or equal to? Write it on your paper. How could I write less than or equal to? All right, go ahead and write that symbol. Does yours match what I just wrote?
Yeah.
Okay, -7, and I'm done. All right, you don't have to solve anything. We're going to do that in section 4.5 and 4.6. Okay? So now I want you to write the inequality that would go with the second phrase. A number, again, it gives you the variable it wants you to use, x, is at least -10. Again, guys, this is a point where I'm fine with you using your chart to make sure that you get it right. You do have to have it memorized by Monday, but you don't have to have it memorized tonight. Okay? So you have to know which inequality is at least, and you can think of it practically also. Does anybody know what did you write for your inequality? Want to volunteer that, Zach? Okay, he said greater than or equal to -10. X is greater than or equal to -10. Would you agree with that?
Yep.
It has to be at least -10, so it could be greater than or equal to -10. That would be fine. That's awesome. Twice more than y, I'm sorry, twice a number, which is y, is more than, and this should say -5/2, the fraction messed up, more than -5/2. So again, we're just writing the inequality. All right, we're not solving anything. Twice a number, y, is more than -5/2. You have to figure out twice a number. Well, does that mean addition? Does that mean subtraction, multiplication, division? Write it on your paper. Okay, what operation? What do you think, guys?
Multiplication.
Yeah, twice a number. And it tells me to use y. More than. Would that be greater than or less than? Greater than -5/2. Okay? So do you understand what we're doing here? We're pulling the inequality basically statement from a phrase. Okay? We're just basically translating it. All right, you have a couple of these on homework and your review sheet that you'll be working on tomorrow. All right, and your quiz, Monday. Any questions? Okay, so now example 2 is testing solutions. Guys, you do not have to write these first 2 statements. Okay, but I need you to understand it, absolutely. Okay, the solution of the inequality makes the inequality true. I know that seems like kind of an obvious statement, but I need you to understand that. We'll talk more about that in a second. And there are infinite solutions to inequalities versus equations where there's one number that makes the equation true. Okay? For an inequality, how many numbers are greater than 5? This is just a random example. How many numbers are greater than 5, guys?
20.
Like an infinite number, right? Right? Or less than 5. So with inequalities, there's not just one solution. So we represent that. But for testing purposes, I'm just going to pick a random number, and your book gives you that value. Tell whether -2 is a solution of y minus 5 is greater than or equal to -6. So what do? We take the value they want us to test and we plug it in for the variable. Is it true that negative 2 minus 5 is greater than or equal to negative 6?
Yes. Oh, wait.
Hold on, write it down. What is, are you writing it down? Should see your pencils moving. What is negative 2 minus 5?
7.
Negative 7. Is negative 7 greater than or equal to negative 6? Think of it on a number line. No, it is
Greater
not.
than.
Hold on, hold on. Here's what we're doing, guys. All right, this is all we're doing. We plugged in the number. Did that number make the inequality true? That is not true. Negative 7 is not greater than negative 6. It's farther from 0, right? It's less than. So that solution did not make the inequality true. Does that mean that no number makes it true? No. What's a number that would have made that true?
Negative 5.
Negative, not negative 5. What about positive 5? What's 5 minus 5? 0. Is 0 greater than negative 6? Okay, so that could have been a solution. What about 10? If I had plugged in 10 for y, what's 10 minus 5? 5. Is 5 greater than negative 6? Yeah. So there's plenty of numbers that made it true, but the one they gave me did not make it true. Okay? I want you to test the second one. Is negative 2 a solution of negative 5.5y is less than 14? Plug it in, simplify it, and then tell me yes or no. Okay, negative 5.5 times negative 2, did you multiply it? Is less than 14. Remember, a number and a variable together means multiplication. What's negative 5.5 times negative 2?
Negative 11.
Positive 11. Is it true that 11 is less than 14? Yes. Okay, now here's the problem. Is it also true that negative 11 is less than 14? But did you get it right?
Yes.
No. Because negative 5.5 times negative 2 is not negative 11. So the problem with testing solutions is if your simplified answer is the wrong value, even if you answered yes or no correctly, you didn't get the answer right. Does that make sense?
Oh, yeah, because it's
11 is supposed to be positive. If you wrote negative, you technically did not get it right. Okay? So that's why this step right here is so important. Okay, and not just the substitution. I need to know that you're actually working that out. And guys, you can use your calculators. There's no reason you should get that wrong. Okay?
Sorry.
All right, so testing solutions. We have one more example to go through. Okay? Here's what I need you to write down from this, and then I'm actually going to switch over. We'll come back to the word problem if we have time. All right? An open dot. So I need you to write like an open dot on your notes. An open dot means less than or greater than. Okay, do you see the less than and greater than symbols next to the open dot? A closed dot means greater than or equal to or less than or equal to. Basically what we're looking at here is the bar underneath the inequality sign. If it's there, that means that it's a part of the solution, and that's why it's a closed-in dot. You're going to see what that means on the graph in just a second. But the open and closed dot has to do with the inequality. If it's equal to, it's closed, meaning that number is a part of the solution. If it's open, that means the number is not a part of the solution. Okay? It just has to be greater or less than that number. All right, I'll explain in a minute. Just make sure you have that written down. Everybody got it? Okay. So let's graph the inequalities. I know when you think graph, you probably think graph paper, right? Well, no, it's not. We're graphing on a number line, which we can easily do on regular paper. Less than or equal to negative 9. You need at least 3 numbers on your number line. And guys, we always write our number lines in reference to 0. And where is 0 in comparison to these values? Okay, so the very middle value is what we believe is our solution. Okay, r is less than or equal to negative 9, so negative 9 goes in the middle. All All right, so this is the part that sometimes confuses people. Think of negative numbers on the number line. If I'm going in order on the number line, what number would be to the left of negative 9? Negative 10, right? Okay, because I'm getting farther away from 0. And what number would go to the right of it? Negative 8. So that kind of just gives me some parameters here, okay? So that's why you need at least 3 numbers, not just 1, okay? Now I need to figure out, is it an open dot or a closed dot on the negative 9? Well, the inequality symbol tells me if the equal to bar is there, it's going to be a closed dot, and that symbolizes or shows your reader that negative 9 is a part of the solution. Isn't it true that negative 9 equals negative 9? Isn't that true? Okay, so that's why I'm closing it in. It's a closed dot. And again, the inequality symbol, R is less than, that tells me that all solutions less than or equal to negative 9 would make it true, right? So give me a value that makes the inequality true, any value. What number is less than or equal to negative 9?
Negative 21.
Negative 21, negative 10. All those numbers are farther to the left on the number line, aren't they? So that's why I draw an arrow to the left. Okay, so what I'm showing on the graph is that negative 9 can be a solution, but that's the cutoff. Okay, now any other number less than negative 9 would make that inequality true. You guys just kind of shouted out a couple numbers. Do you agree that all of those are to the left on the number line of negative 9? Okay, all right, so let's do another one now. X is greater than 5. Okay, how many numbers go on your number lines?
3.
How many numbers are going on your number lines on homework? 3. On your review sheet? 3. On your quiz?
3.
And on your test?
3.
Okay, very good. So don't put 1. You don't even have to put 5. Say, what if I want to put 5? Go right ahead. Okay? Write the number that goes in the middle. Go ahead and write the number that goes in the middle. What number goes in the middle? 5. All right, now think about it before you shout it out. And I don't want you shouting the answers out. On a number line, again, wherever 0 is, what number, don't shout it out, you should be writing it on your paper, goes to the left of 5. Hold on. What number is it?
6.
That's why I said think about it, guys. Okay, I was hoping to get everybody to get it. Yes, it's 4. And then to the right of 5, 6. Think about it. Think about it. Where is 0? 0 is way down over there.
Because that's negative.
Yeah, exactly. Okay. All right. Now, my inequality symbol tells me, is it an open dot or closed dot, and which way the arrow goes. Okay, so I want you to go ahead and write on your paper if it's an open dot or closed. Go ahead and put that on your graph. Okay? Because I just told you what we're looking for in the last one. Because it's only greater than, is it going to be open or closed? Open. It's not equal to. So that means that 5 is not a part of the solution. If I said 5, it's not true that 5 is greater than 5. 5 is equal to 5. That would not be true in the inequality. Okay? But any number greater than 5 would be a solution. Give me a number greater than 5. 6, 20, 12. Okay? So my arrow goes to the right, showing my reader that all my solutions greater than 5 would make the inequality true. And you just gave me several numbers that I could have plugged in here for X. Okay, does that make sense? So on the graph, I'm showing what my possible solutions are without killing myself and writing 1,500 numbers. I'm just writing 3 numbers and showing where my solutions are trending. Okay? All right, you guys got it? All right, that's everything you need to know for 4.4.
Yes.